So today we will continue to talk about the other important concept in chapter 8, which is torque. So what is torque? Torque is the tendency of a force to cause rotation. As we learned from Newton's second law, we know that force is the reason why we can change the motion of an object, but torque is the reason why we can change the rotational motion of an object. So think about example here in real life. So if you want to push the door open, right? So if you notice that all the doorknobs actually they are located almost to the edge of the door frame, which is very far away from the hinge. So if you imagine how the door is rotating, so where the hinge is located is acting as the axis of rotation. And then when you push the door open on the doorknobs, you are applying a force, but also you're applying a force at where the doorknob is located. Nobody's going to push the door open actually when you're going to apply the force very close to the hinge. And you don't see a doorknob actually is located very close to the axis of rotation where the hinge is located for the door. Okay, so what indeed is torque? The torque depends on three factors: the magnitude of the force, how big the force is, the direction in which it acts, so the direction of the force, and also at where you're applying the force. So there are three things. How do we calculate torque? The torque is calculated by lever arm times force. So what is a lever arm? Lever arm depends on where the force is applied, the direction in which it acts. So here I want to show you some examples how we can calculate torque. So torque is defined as lever arm times force. So what is lever arm? Lever arm is the shortest distance between axis rotation and the force. So the lever arm is the shortest distance between axis rotation and the force. So I'm going to use the door example to show you how we can find the lever arm, how we can calculate torque. So for instance, if I look at the door from the top, so here is where the hinge is located, and this is axis rotation. And you're applying the force, let's say, this direction. So what is going to be the lever arm? You start from the axis rotation, you draw a line perpendicular to the force. So the line you just drew is called the lever arm. Okay, so that's one example. I can give you another example. Let's say, again, this is the door, but you are applying the force this direction. Okay, so what is the lever arm? The lever arm is you start from the axis rotation, you draw a line perpendicular to the force. Draw a line starting from the axis rotation, draw a line perpendicular to the force. The line you just drew is called the lever arm. Okay. I can give you another example. So again, this is where the door hinge is located, and you have this force here. You're applying the force like that. So what is going to be your lever arm in this case? You can extend the force in both directions if the force is not long enough. So this line is called the line of action of the force. And then you start from the axis rotation, you draw a line perpendicular to the line of action of the force. And this is the lever arm. So that's the first thing, how you find lever arm. Okay, so the shortest distance between the axis rotation and the line of action of the force is called lever arm. So that's the first step you need to calculate in order to calculate torque. The second step is force, which is pretty straightforward. Now, let's say if I'm applying a force here, what is the level arm? I'm applying the force exactly on the axis of rotation. So the level arm, again, is the distance, shortest the distance between the axis of rotation and line of action of the force. So in this case, the level arm is 0. If the level arm is 0, that tells you the torque is 0. So in other words, if you have a force, you're applying a force actually passing through the axis of rotation, then the torque as a result of that force, in fact, is 0. So in other words, the force applying through the axis of rotation does not generate any torque. The last thing here is you need to, when you find out torque, you need to decide whether this torque is positive or negative. Okay, so when we have a force which is generating, okay, let's say this case, it's generating a counterclockwise rotation. So here again, this is axis rotation. If you have a force, under this force, this whole thing is going to rotate counterclockwise. So we say the torque generated by this force is positive. If we have a force which is going this direction, under this force, you see this whole door thing is going to rotate this direction. It's clockwise direction. So this force is going to generate a negative torque. So why do we need to talk about positive torque or negative torque? Okay, so if you still remember Newton's second law, right? So because of the force, that's why we have acceleration. But if the net force is 0, we know the acceleration is 0, and we also know the object is at equilibrium. But now, similarly, like what we talked about last class, if I replace force by torque, I can replace mass by rotational inertia. I can replace acceleration by rotational acceleration. And then I have Newton's second law for rotational motion. If I have equilibrium, then that torque has to be 0. Okay. So in other words, if I have an object which is undergoing both linear motion and rotational motion, so the equilibrium condition for that case would be net force is going to be 0, net torque is also 0. So that's the equilibrium condition. Okay. Before I give you an example, I want to go through some of the more slides here. Okay. So this shows you some examples about how we can find our level arm. Okay, different examples as I show you on the whiteboard. And this is one of the examples, okay, you guys can practice on. But I want to give you another example, okay. So let's say if we have a balance beam. There are 2 kids on the balance beam. One is standing here, 3 meters away, and the other one is standing over here, 1.5 meters away. This person 1, this is person 2, weighs 250 newtons. We want to find out how much does this person weigh if the balance beam is balanced. So when we say the balance beam is balanced, we are talking about the net torque is going to be 0. Okay, so how do I find net torque? We learned about how we find out net force, right? We just basically finding all the forces and we add them together. Okay, so that's the example. Okay. Um, so again, here we have a balance beam. We have a person weighs 250 newtons. We have another person. Actually, we're looking for its weight, but each person is this amount away from the pivot point, and then we want to find out how much does this person weigh in order to balance this beam. So we need to find out net torque is going to be 0. How do we find net torque? Net torque equals torque 1 plus torque 2. So we are finding the torque generated by each force, and we add them together. That's going to give you the total torque, net torque. So then we find out the torque generated by each force one by one. Okay, so the torque equals force times level arm. So for this case, we have the axis of rotation over here. That's the axis of rotation, right? And we start from here, draw a line perpendicular to this force, which is 3 meters. Draw another line here, and which is 1.5 meters. So this is the level arm for this force. That's the level arm for that force. Once we know the level arm, we know the force, we can set up the equation here. So this is 0. The first torque is 250, okay, times 3. But remember, okay, now we need to decide the sign for the torque. So for this case, forget about the second person here. Only under W1, which direction this balance beam is going to rotate? It's going to rotate this way, counterclockwise. So that's why it's positive. Okay, but now the second one is W2, we don't know, times 1.5 meters. But for the second force over here, forget about the first force. Only focus on the second force. If we only focus on the second force, so which direction the force is going to rotate the balance beam? So it's going to rotate this way, so which is clockwise. That's why the torque is negative. So this equals 0. When we solve for W2, which will give you 500 newtons. Yeah. Okay. So that's going to be 500 newtons. So this person has to be 500 newtons in order to balance the beam, supposing everybody is standing 3 meters and 1.5 meters away. Okay, based on that diagram. All right, so that's the one of the examples. I want to give it to you. So hopefully you can learn from this example about how we can calculate the torque and how we can decide the torque based on its rotational direction. And there is a worksheet from this chapter which is about torque. Page 42, I'm going to ask you guys to work on after class, and then I will come back next class if you have any questions.